applications of first law of thermodynamics means how the first law of thermodynamics is applicable to all the different processes. Now first one is isothermal process. Isothermal process. Now we know that in case of first law of thermodynamics, dq is equal to du plus dw. So when isothermal process is taking place means temperature remain constant. Temperature is constant, and we have studied that in case of an ideal case, the internal energy U depends on temperature only. So since temperature is constant, so change in internal energy du is equal to 0. For that case, dq is equal to dw. It means in case of isothermal processes, the heat supplied to the system is used in doing the work only. Second is adiabatic cases. Adiabatic process. In adiabatic processes, no heat exchange takes place. Since no heat exchange takes place, it means dq is equal to 0, means change in heat energy is equal to 0. So from first law of thermodynamics, which is equal to dq is equal to du plus dw, since dq is equal to 0, so du is equal to dw minus of dw, or du is equal to minus dw. Since in case of expansion, the work done is taken to be positive, so internal energy will decrease, and this is valid also, since during the expansion temperature decreases, so internal energy decreases. So both the points are valid. Now third case is isochoric process. Isochoric process means volume is constant. Since volume is constant, so work done which is given by PdV, volume is constant, so change in volume is 0. So work done is 0. So in that case, dq is equal to du, means total amount of heat energy supplied to the system will be spent in increasing the internal energy. Also, since volume is constant, so whatever heat you are providing, it is rising its temperature, so internal energy will increase. Next is cyclic process. Fourth one is cyclic process. In case of cyclic process, since the system returns to its initial state, so total energy, internal energy is 0, no change in internal energy. So again dq is equal to dw in this case, means the amount of heat supplied to the system is consumed in doing the work done, either in expanding or in compression processes. Next application is melting process. We know that when the solid melts into liquid, at that state the temperature remain constant. Means if we put the thermometer and measure the temperature, it is found that during the change of state the temperature remain constant. So the amount of heat that is supplied to the system is known as latent heat at that time. So we will find out, let m is equal to mass of solid, and if L is the latent heat means the heat which is hidden, which is being spent but not measured, latent heat of solid, then heat absorbed dq is equal to given by m into L. Since during the melting process the change in volume is in very small, so comparatively dV can be considered to be 0. So work done is equal to 0. So from first law of thermodynamics, which is equal to dq is equal to du plus dw, since work done is 0, so dq is equal to du, or we can say ml is equal to du, or du is equal to m into L, means in that case the internal energy during the melting process is given by m into L. Since the temperature is constant, it means internal energy should be at the cost of its potential energy. So this is the application through which we can calculate how the energy varies during the melting processes. Next one is boiling process. In case of boiling process also, we can calculate the internal energy, right? Now in case of boiling process, liquid changes into volume at constant temperature and constant pressure. Okay, so we have to keep this in mind that in boiling processes the liquid changes into vapors at constant temperature and constant pressure. Now if m is the mass of liquid, ठीक है, at its boiling point V1 is equal to volume of liquid at its boiling point, P is equal to constant pressure. V2 is the volume of the vapors of the liquid in the vapor form under the same pressure. So we'll write here in short form it is vapors. So L is the latent heat. Latent heat means छुपी हुई heat which is provided during the change of state. Latent heat. So in that case dW is equal to P dV. Since volume is being changed, so P V2 minus V1, and dQ is equal to m into L. So according to first law of thermodynamics, dQ is equal to du plus dW. Now dQ is equal to m into L is equal to du. Du is given by, du is the internal energy, so that will be written as it is du plus work done is P V2 minus V1. So internal energy we can calculate, du is equal to ml minus P V2 minus V1. So this is the expression for internal energy in case of the boiling process. Next application for thermodynamically, first law is free expansion. Free expansion means it expands freely. So in that case the free expansion is the case of adiabatic process, basically adiabatic process in which no heat exchange takes place and no work is being done on the system. So in that case dQ is equal to 0 and dW is equal to 0. So in that case du is equal to dQ minus dW is equal to 0. So internal energy, change in internal energy is also 0, and we can't draw the graph for such processes.